In general, equation of motion is a straight line. So normally we consider equation of motion of a point or some object is a straight line in general, right? Consider an object which moves in a uniform speed. That is important. Uniform speed. X-axis denotes the time taken, right? And y-axis denotes the distance traveled, right? So we will mark x dash as x-axis, and y dash as a y-axis. O is the origin. So x-axis, time taken in hours, let it be. Distance traveled marked in y-axis in kilometers, let it be. Then the graph of movement of the object is a straight line, right? So we are considering a two-dimensional movement, right? So for example, consider a car is moving on a uniform speed 60 km per hour. The speed is uniform. There is no change in the speed, right? And with respect to time, then it is called uniform speed, right? So in 1 hour time, distance traveled by the car is 60 kilometers. 2 hours, 120 kilometers. 3 hours, 180 kilometers. Like that. The speed is uniform with respect to time, right? So we are marking 1 hour 60 kilometers. The point is 1, 60, right? Similarly, in 2 hours time, traveled 120 kilometers. So 2 in x-axis, 120 in y-axis. So mark that point 2, 120. So like that you can proceed like this 3, 180, etc., etc. We can mark this and join the line, right? Join the points. So you will get a straight line. So that line is L. We know that speed, we know distance by time, correct? Speed is 60 kilometer per hour. That means 60 kilometer distance per hour time, right? So speed is distance by time. So this is distance, this is time, right? So vertical rise by horizontal distance. Vertical rise. So in vertical we are mentioning the distance, y distance 60, 120 are vertical. And horizontal distance time, so 1 hour from the origin, right? 0 to 1, right? That distance 0 to 2, right? 2 hours. So that is 1. This is vertical rise, this is horizontal distance. We know that from the basic definition of slope, slope is nothing but vertical rise by horizontal distance. We know that is 2 from 1 and 2. So uniform speed is nothing but the slope. The speed is uniform, noted, right? So next problem. A sea bridge is a railway bridge of length about 2065 meters which connects an island to city, right? The bridge is restricted to a uniform speed of only 12.5 meters per second. If a train of length 560 meters starts at the entry point of the bridge from the city, then find an equation of the motion of the train. Equation of the motion of the train. Second one, when does the engine touch the island? Third one, when does the last coach cross the entry point of the bridge? Then last one, what is the time taken by a train to cross the bridge? We'll see the solution. Let x-axis indicates time in seconds and y-axis indicates the distance in meters, right? X dash time in second and y dash distance in meters. O is the origin. Let the engine be at the origin O, right? Starting point, we are consider engine as a point, the starting point of the train, right? So this will be like this. Engine will be at the origin. Engine and tail end, that is the last coach. Given the length of the train is 560 meters. So this is 560 meters. Since the engine starting point is at origin O, the full length of the train is below the origin, correct? So engine is at the starting point, right? So that is below the origin, that means negative side of the y-axis. The line of motion L cuts the y-axis at minus 560 degree. So we are considering the line of motion like before, right? In the example I have given 60 kilometers per hour, 20 kilometers per hour. Here 12.5 meters per second, then 25 meters per second, right? Like that. So you will get a point, then you are connecting that point, you will get the motion of a line, that is equation of motion, right? That is the line L. So line starting from the point, not from the starting point of the train, right? From the tail end you have to calculate, right? Because total length is 560 meters, so we have to consider the tail end. So it is at 560 meters below the origin, so the line of motion cuts at minus 560, right? In down negative side of the y-axis, so minus 560. So line of motion is like that, not from the front, right? You have to consider the whole length of the train, so you have to start from the end point of the train. The line start from the end point of this, that is why, right? Line of motion, y-intercept of the line of motion is minus 560, so this is y-intercept. Given uniform speed of the train is 12.5 meter per second, so slope is equal to uniform speed, that is equal to 12.5 meter. So slope of the line of motion is m is equal to 12.5, right? Now define the equation of the motion, right? We know slope y-intercept form of a line is y is equal to mx plus c, where m is the slope and c is the y-intercept of the line. Here so m is slope, that is 12.5, and c is minus 560, right? So equation of the motion is y is equal to 12.5 x minus 560, that is equation number 2. To find the time when the engine touches the island, right? So now the engine is at the starting point of the bridge, origin O, right? Now it has to touch the island, means the engine has to cross the whole length of the bridge. Only engine, right? I am talking about the starting point, right? So we know the length of the bridge is 2065 meters, so engine should cross the 2065 meters, then only it will touch the island. It will touch the island, not cross the island, touch the island, right? To touch the island, only engine must cross the whole length of the bridge. So the engine must cross the distance 2065 meters. Here the distance y is equal to 2065. Always y-axis always represent the distance and x-axis always represent the time. Slope m is 12.5 and we need to find the time, right? The time the engine, right, when the engine touch the island, that is x, right? So also note that here we are considering only the engine, right, starting point, and not the whole length of it train, right? So y-intercept is 0, so starting point is at 0, right? Engine at 0, so origin no, so that is why we are considering the y-intercept c equal to 0. So y is equal to 2065, m is equal to 12.5 and c is equal to 1 in 1, equation number 1, slope y-intercept form. So 2065 is equal to 12.5x plus 0, so x is equal to 2065 by 12.5, that is equal to 165.2 seconds. In 165.2 seconds, exactly at 165.2 seconds, the engine touched the island. Next, to find the time when the last coach crosses the entry point of the bridge, right? So entry point is origin, right? Now engine at entry point. Now the whole length of the train should cross the entry point. Then only the last coach crosses the entry point, right? Last coach, that is tail end, crosses the entry point of the bridge only if the engine covers 560 meters, right? From downwards to upwards, right? Meter distance forward. Here the y is equal to 560 meters and slope m is equal to 12.5, and we need to find the time x. Here also we are considering the point tail end and starting point. So engine length, there is no engine. Also note, we are considering only engine as a starting point, not the whole train, right? So whole train length is 560. We are not considering that one. So we are considering the starting point engine, tail point is that last coach, right? That's just like a point. So we are considering the engine as a point. It is in the origin. So the length of the train is 0. That is y-intercept is 0. So x dash, y dash, right, like this. So the last coach crosses the entry point of the bridge. So it will be like this. So here this is the engine, this is tail end, this is 560 meters. So engine should cross the 560 meters, then only the last coach will touch the entry point O. Right? So y is equal to 560 and m is equal to 12.5, c is equal to 0 in 1. So 560 is equal to 12.5 into x. So x is equal to 560 by 12.5, 44.8 second. So last coach crosses at 44.8 second. To find the time taken by the train to cross the bridge. So the whole train should cross the bridge. So given bridge length is 2065 meters. To cross the bridge, the last coach, right, tail length of the train must cross the whole length of the bridge, right? End point. When touching the island, so engine should cross the whole bridge. To cross the bridge, the last tail end should cross the whole bridge, right? That is the difference. So distance y is equal to 2065 and slope m is equal to 12.5. We need to find the time x. So note, we are considering the whole length of the train because whole length should cross the bridge. So 560 meters, right? So c is equal to minus 560. We are considering whole length, that is y-intercept of the line. So that is 2065 equal to 12.5 into x minus 560. So 12.5x is equal to 20565 plus 560, that is equal to 2625. Therefore x is equal to 2625 by 12.5, 210 seconds. So time taken by the train to cross the bridge is 210 seconds. Thanks.